Oh! I didn't see you there. Are you watching me playing games? All right, I'll stop it there. I just thought, given the themes involved in what we're doing with assignment one slide, I thought I would I thought I'd start off with a little inspiration for why we're working on this particular assignment and the kind of things that we're doing. So that's called R-Type. It's like it's not the oldest. It's definitely not the oldest of its kind. But this was, I think, they don't have the year here on this site that just kind of collects all these old old arcade games. But I think it's 1987, if I'm correctly. So it's not even what we'd consider the golden age of the arcade, where most of these were vertical shooters. But I wanted to get one of the kind of archetypical horizontal shooters, because Slide is kind of like a horizontal shooter. Ooh, I heard a sound. I'm not alone in the stream today, but let me. Hello, Tom. How's it going?
Hello, things are going well.
Awesome. Just making sure everyone can hear Tom. I'm pretty sure you can, because I saw the sliders going up on the audio there. So that's probably all good. I might just turn you down a little so you don't feed back into my microphone. My speakers are really close to my microphone, so this could get messy, everyone.
Sure.
This is like a sort of impromptu setup, but it should work pretty well so that we can jump to Tom anytime he has something to add here today, rather than like kind of restricting him to having to do the stuff in the live chat. We've got him here today on screen, so I don't know if you're watching the stream at the same time, Tom, which will get really confusing because you'll be a few seconds behind, but you'll be able to see your own face.
I'm going to pull it up just so I can see what you're showing, because I can only see myself at the moment.
Yeah.
As wonderful as side as that is, it's probably a good idea to be able to see your slides and stuff as well, or your code.
Well, I don't really have slides as such. I have, because we're not. This isn't like a fully prepared stream for everyone out there. This is an optional thing that's going to hopefully help a little bit. So I have a plan, which I'll show here. It's a very, very simple plan. Let me maybe
Left click, there we go.
just increase the font sizes on everything here, so that I'm just looking at my streaming screen, because that's about all that we need to see at any point. So the purpose of what we're doing today is to have this kind of live stream that gives people some help with the assignment. It's entirely optional help. It's not something that you need to or have to do to work on the assignment, but really, I mean, if there's anyone like Srikar there was saying, this assignment is not a vibe. So if you're in that position and you're looking for some help in terms of getting started and things, hopefully some of the stuff that we're going to talk about today is going to explain some of the things that might happen in the assignment and some of the structure of how it works. So let's kick it off by talking about what Slide is as an assignment. So this is the assignment here, and it's got a little preamble talking about how arcade games became, like one of the biggest things that happened to computing, even in the late 70s through the early 80s, where if you want to measure it in terms of like how much money it was making, because that's like kind of a measure of popularity and things. So these things are people just putting coins in to play. Like they didn't even they weren't really at this point able to take them home and play them at home or anything. So this is pre-Nintendo. At that point in time, I think was the first point at which the games industry made more money in the US than both the music industry and the film industry combined. And so that's a statistic that has been going pretty much since then, that the games industry is bigger than all the other entertainment industry stuck together. And so I always like to point that out. As much as I do love films and music, it's always fun to point out that computer games have been the entertainment of choice for humans basically since they were invented. So yeah, Slide is a simulation, I guess. Like, we had to, of course, simplify this so that it's actually possible to do with 4 weeks of learning about C programming. But it's a stripped down version of a 2D side-scrolling shoot-'em-up arcade game. Cameron is asking if this is recorded. Yeah, this is all recorded. So it's like very similar situation as the normal lectures, where everything that I do here is going to be A, up on the YouTube channel, and B, uploaded to Moodle as well, so people will be able to see it all there. So the setup, the background of what's going to be happening in Slide is this map. And the map is a two-dimensional array, and each square, or even, you could even call these pixels on a screen if you wanted to, but we're going to call them squares on a map most of the time in the assignment documentation. Each one of these can contain an integer, and it's similar to the lecture example that I showed yesterday, where that integer that's in there might have a hash define that makes it mean something. So most of the time it's a matter of each square on the board being either empty or containing something. At its simplest state, they're going to either have stones or be empty. And then the deeper you get into the assignment, the closer you get to something like R-Type, where everything moves from the right edge of the screen to the left edge of the screen, and you're controlling something that can move on the screen. We've simplified that a little to you just controlling this thing called a laser, which is actually not on the map. It's just attached basically to the left-hand side of the map, onto one of the rows, and then you can actually write code so the laser can shoot onto the screen, and it can blow up some of the rocks, some of the stones that are heading from the right side of the screen to the left side of the screen. Ellen was asking if we could zoom. I assume that this is too small to see at the moment, right? Hopefully we're at 200% zoom here. Hopefully this is making it a little bit easier to see, because I'm not really working with slides today. It's not a fully, pre-prepared, produced thing. This is much more of a live stream than it is a lecture. So
that does look a lot better.
Oh, good. So you can read it now. That's good. In case anyone's wondering, Tom is here. Tom is the subject admin for the course, and honestly, for this assignment over the last week or two, he's done a lot more work than I have on this assignment, so he's been the one getting all these details going in the background and getting them going. So I figured it was a good idea to get him involved to talk about this, because I think you know a lot more about the nitty-gritty than I do. So if I trip up on something, Tom's here to just go, oh, actually, it's a little bit like this. So
I'll try my best.
Yeah.
So people know, I'm like 10 seconds. I'm watching the stream behind the lag, so I may look a bit weird if I can only see myself on the screen like 10 seconds after it happens, just so you know.
Yeah, I think this is something that when I'm live streaming as well, it's try not to look at yourself, because I do have a screen over there that has the stream going, and it's really a little awkward to watch myself. So,
yeah. There's a really good question in the chat, by the way. I'm not sure if you want to answer it now or later about getting help.
Saying, in terms of getting help, we can only get help from our tutors, help sessions, and course forums. That's actually pretty good, Calvin. You've got most everything there. As this is supposed to be an individual assignment, if you do get any help outside of that, you can credit that help in comments. So if you look up a technique for working with 2D arrays or something like that, which isn't from your tutors or the lecture materials or help sessions and things like that, you have to credit it, because that's the point at which we'll have to make a decision about whether your use of that still makes this your individual work or not. But most of the time, the safest thing is really only talk to your tutors about it. And even the course forum is limited in that the course forum has access to all the other students. So if you start posting assignment code on the course forum, then that causes a lot of problems for yourself and everyone else. So just be careful about that as well. You can ask questions that aren't specifically about the assignment, but are very, very close to the assignment, like looping through arrays and stuff like that. You can definitely ask generic questions like that in the course forum. You'll still get good answers there. And
it's worth noting as well.
Yep, sorry.
It's worth noting as well that like if you ask a question that doesn't require you to post your full code, then students can, like other people can answer those questions as well. Like it doesn't just have to be the 4 tutors who are on the course forum all the time. A student who's on there can be like, oh yeah, like I know the answer to this. Whereas if you're just like relying on us being on telling us just look at my code, then it'll take a lot longer for us to answer because there's only 4 tutors on the course forum sometimes, rather than 900 students.
Yeah. Okay, so I was drawing a little image here of what's going on, and we could have a laser. Here, for example, I might also talk about rows 0, 1, 2, 3, and I might talk about columns 0, 1, 2, 3. So this is the map. This is the kind of world that we'll be working with in in Slide. And in general, when we start off with this, I'm not going to draw it in, but all of these might be zeros. But then we can get things like ones in here, and we're really actually not going to be thinking about these as ones that much, because there's going to be a hash define for these. So there'll be something like a hash define stone. I'm running out of space. Stone 1, like that. And so when we're looking at these ones, I'll change my cursor, you can see it. When we're looking at these ones, we will be thinking of them as stones. And there'll be other things that we can possibly do. Hemi is asking, do we need to make annotation in assignment? I'm not sure what you mean by annotation. Are you talking about comments alongside your code to explain it? Oh yeah, Tom's answering that already. Yeah, I would definitely say yes. I think if you try to write code without comments, you're just going to get less marks because you're not going to be able to understand your own code and you're not going to be able to fix it if there are problems. So you'll just burn time fixing things if you don't leave comments for yourself. There's also marks specifically for them to try to encourage the use of that. Swathi Shan says, are we allowed to change the variable names in the starter code? Tom's already... I'm going to let Tom answer those things. So Tom's saying, yeah, you can change them, but just be careful because there's also a function in there that we've given you. So at the moment, that definitely works. Like, we've tested it and made sure it works. If you change it, then you can't always be certain whether it will or won't work. So just be careful if you're going to do that. We'll talk about the starter code in a second. We're just about to get into there. Okay, so we have this kind of situation where we're working with integers in a 2D grid, and we've got this laser which is basically just attached to one of these columns. So we could just use an integer or something. Actually, not or something. There's really nothing else you could use but an integer to represent where the laser is. And then the deeper you go into the assignment, the more fiddly things you're going to do. Or we're going to include special stones, which are piles of TNT that you can actually blow up, and they'll affect other things. So that's going to happen the further you get into the assignment. Alright, I think Tom's answering the questions there, so I don't need to...
I'm happy to answer them over voice. I'm not sure what'll work better. The question there was just about should you use hash defines rather than numbers, and the answer is absolutely yes,
definitely,
you should.
Right? Yeah, you definitely want to use the words because A, easier to read, easier to understand. B, if we're ever going to change a hash define into something else, like say we decide stones are not going to be the number 1 because we need the number 1 for something else, and we change stones to the number 10 or something, like what if we had lots of different things? We want to be able to do that by just changing it once in the hash define and not have to go through the program and hunt down all the times that 1 appeared. So basically, if any time that you're referring to stones, the number 1 should never appear in your code. I should always be the word stone instead of the number 1. So that way, if you ever need to change what the stone is represented as, you only change one line of code, just the hash define, and everything else just sort of flows on from that. So we want to get people into that kind of way of programming, because what it does is it makes your code much easier to modify, much easier to kind of correct and work with. Okay, so we have some pictures of what the data structure is But now we want to think about what the actual program is. So the program that you're writing is this thing called slide, and what it's going to be doing, let me just log into VLab to show stuff, is it's going to be taking input from the user and then giving things back to the user as it runs. So one of the best ways to check how this works, I would go to the assignment specification and show you that there is a command here that says we can run the reference for slide. The reference is something that one of the tutors has actually completed, which does exactly everything that we want the assignment to do. So you can always check your assignment against what this reference is doing. And so let's have a look at this reference, and it'll show you what the behavior of slide from your perspective is. So it's not going to be like this. It's not going to be like... Oh, that one's... Wait, was that paused? Yeah, it's not going to be like this where it's moving around in real time or anything like that. So this moves around with keys and it fires and stuff like that. We're not at that level of detail, right? We're just going to be doing a step-by-step input-output kind of thing. I'm going to pause that and go back. So this is the command here, 1511 slide reference. So I'm going to type that in here. And this is the program that you'll be able to run if you're on our computers. So first thing that we're going to have is a question saying how many blocks do we want to place on the screen to begin with. Let's just start with 2. This is interactive, right? So your program is the thing that's running here. So you will have to write a program that accepts how many blocks and then will accept the information about the blocks. And if you want to look up what exactly this information is, it's actually all in here in the code that you're asked to do. So the first thing you have to do, I keep calling them blocks, the first thing you have to do is place stones on the map somewhere. And they have this format, row, column, value. So if we look at, I'll go back to the image, rows starting from 0, counting downwards, columns starting from the left at 0, counting towards the right. So for example, this square here is 2, 2. And this square here is 3, 1. So if I want to say put something in the bottom left corner, actually I don't know. It depends on how big the actual the reference is, but I'm pretty sure it's 15 by 15, right, Tom?
I believe it's 14 by 14. It might be 15 by 50. It's one of the two.
I don't know if the last index is 14, but anyway, I should be able to place a block at 10, 0, and for the moment, because I haven't shown you any of the other blocks, we're just looking at what's in stage 1 here, which is the very first part of the assignment you would do. Number 1 is the value saying this is what the stone would be. Because we're typing in text here, we can't unfortunately do this. So we're still just going to have to give it a 1 here. And because I said 2 blocks, it's going to expect another block, so let's put one just at 2, 2, so this will be near the top left corner. And then this is the part of the program that we've written for you, in a sense, the ability to print out the map. So what you'll have to do initially is send this information to the user, process the input, send this information to the user, loop through and process as many pieces of input as necessary to read in the locations of these blocks. So I said 10, 0, so it goes down 10 rows and then it's in the first one. 2 goes down 2 rows, then across 2 rows, like that. And the laser has a default starting position here. I haven't even looked at yet in the assignment spec as I'm showing it how we're going to do that. But this is the behavior your program will have to do. So it'll have to do this first, and then it'll just wait here at a prompt. And while it's waiting there at the prompt, it's actually waiting for us to give it more input. So what we're implementing is like, if we go back to this game, we're implementing the engine that would be running behind a game like this, and then every time something wants to change in this game, some kind of command goes in here to make something else happen. So there are things like shifting everything to the left, There are things like moving the laser up and down and shooting the laser and all these things like that. And what we're doing is we're providing the code that says, given, say, the rules of the game or that kind of thing, this will behave correctly if you ask it to do things. So if we try to shift to the left, all of the stones that we have should move one position to the left. So that kind of thing there. Yeah, Jeffrey, I apologize. I keep saying blocks instead of stones. Mac and Cheese is asking, you're a little late. Is the extension stuff being given in this stream or next week? It will be shown in this stream, but it's going public on the assignment spec webpage. Is it already, Tom?
So I have I've just released it. We've got a little note at the top saying it's like a final draft because the only thing we haven't really done is the submission system yet. That's in the process of being set up now. I don't expect the extension text to change at all, I don't think.
No, I don't think so.
Unless there's something massively breaking, which hopefully won't happen. But certainly the submissions won't work until, I've said Saturday. It'll probably be Friday night or Saturday is when I'd expect that to happen.
Yeah.
Unfortunately, it does take a little while for us to set this up because there's a lot going on.
Yeah, there's a lot of fiddly things in the background. But we thought it was actually nice to separate the release of the core and the extension because there is a sort of fundamental difference to how they should be approached. We'll talk about that in a second, actually.
Yes.
See if there's other questions there. Oh, no, that's all right. Oh, Jeffrey was asking, can the user input 15 or 14 stones, or is that an invalid input we'll have to account for? So I think there is... Where is it? There's a maximum number of stones? Oh, wait. I scrolled up too far.
That would be under stage
Placing stones?
2, I guess.
It should be under placing stones, right? Oh, we've got
invalid
blocks
inputs
and
under
we keep
stage
calling
2.
them stones. We probably should have used only one word there. The blocks and stones are the same. Oh, no, hang on. Stones are only the first type of block. So it was correct, and I was actually distinguishing the two in my head. But there are many types of blocks, and one of the types of blocks is the stone, right? Yeah. Okay.
Yes, that's correct.
So I think that we have not said specifically in the spec here if there's a maximum number of stones possible. But if we look at the starter code, I think the starter code has that, doesn't it, Tom? I should...
the starter code... It might be useful to pull it up.
Yeah.
The starter code, I don't think has a check for the maximum. It checks for. I think it's the solution checks for a negative amount of blocks. I don't think it checks for more than a certain number of blocks. And I believe that what will happen is if you run the sample solution, when you type in the same block twice, I think it just lets that slide, as far as I remember.
Okay.
I think it just lets that happen. But this is one of those situations where looking at what the sample solution does.
It is allowing us to do 999 blocks, so there's no maximum number of blocks.
Yeah, and if you type in the same block twice, I think it will just write over that same block.
So it's probably
and then
that's going to cause a problem. That'll just be an invalid block.
Have to type in.
Yeah. So it is allowing me to type this in. I probably should have used a lower number of blocks here.
Yeah, I think
because we won't see whether this works or not.
But I think what you'll find is that will work. Checking for blocks outside of the range, I may be wrong, but I think that's part of stage 2. So I think in stage 1 we don't talk about that, but in stage 2 we do talk about that.
Yeah. So in terms of the placing of blocks, we can see here, and this is something that you can do as well if you have any issues with how you think the assignment should behave, or whether you think there's weird things you should be dealing with. 1511 slide reference should give you enough information. I mean, this is a bit of a silly example because it's going to take you so long to type this in. That's why I Control-C to just cancel out of that. So that one maybe isn't necessary, but this situation might come up, and all you need to know is that you don't need to worry if it's a duplicate block, because the result in this square here will be the same thing, so it's not that big a deal.
I should just correct myself, by the way.
Yeah.
With part of stage 1 is detecting if the input is outside the valid range.
Right.
So you can type as many times as you like. You can say 10, 10, 1. That is like you can say a valid block multiple times.
Yep.
But if you say an invalid block,
right, so the
there's
second you
instructions
create
in the
an
assignment
invalid
for what
block,
to do.
there'll be an issue.
Yeah, the instruction tells you the instructions tell you what to do in that case, which is to ignore it.
That's the nice thing about the reference solution, is it lets you know you don't have to worry about that situation. This will not be tested.
If you do it with 2 blocks,
right? Hang on.
Do it with
one
2
valid
blocks and one
invalid?
map and one off. Yeah.
Okay, so
Yeah,
we'll
so-
do
so
one
what-
valid block, and then one invalid block.
Yep.
And this does work. So all it does is ignores the invalid block, and so that is something
right,
you'll have to deal with in code. Yeah. So if there are invalid blocks, you have to say, okay, there's an issue. I think the condition that won't be tested is we'll never give you an empty map to begin with, so we're never going to run any tests with an empty map. Because the empty map would be weird, because it's just like, oh, the game's won from the beginning, what's the point? Okay, so I was just about to jump into here. I've got an empty assignment 1 directory here. So there's a command that you can run in your directory here that copies the starter code from where we have it available and copies it into that directory. So I can just copy this, paste it here, and if you want to, you can type it out. I mean, you can see, as you know from the Linux stuff, that we are going to be doing a copy with a certain flag. I can't remember what the end flag does. From this location where we have the code, and the dot puts it in the directory it's in right now. So if you make an assignment 1 directory and then run this command, as I do there, it's going to put slide.c in your directory. So before I go too deep into that code, we start to see how this runs. The first thing is it takes blocks and it places the blocks somewhere in the map, and then after that it's going to take commands that do things. And we can have a quick look at some of those commands in these stages, where we can move the laser up and down with one of the commands. So that's command number 1. We can fire the laser with command number 2. So command number 2 doesn't take any other numbers. It just takes the laser and fires it. The complication in firing the laser is trying to figure out what it does to the blocks that are in the scene. And then later on we're going to be shifting things left, so we're going to get that kind of movement as you progress through the game. And I can't remember what else there was. Stage 2, I think, doesn't have anything else. And stage 3 is where we go, okay, now we get some funky stuff happening, where we go, okay, now's a different type of block. And that's the TNT block. And the TNT block's interesting because when you shoot it with the laser, it then explodes. And when it explodes, it can hit some other blocks around it and destroy them. And there's the specific rules for how that works, and you can look at the reference for how that works. But this builds up to being something that ends up being sort of a simulation of the idea of this kind of shoot-'em-up game. But let's have a look at the code here. So I've copied the code using the command that I took from the assignment spec, and it'll be here in the starter code section there. You can download it as well as a C file, so if you're not on our systems and you just want the C file on your computer, you can click on that and download it as well. So both of those things are going to work. Let's have a look at the code. Those of you who were in yesterday's lecture will have seen something that's actually reasonably similar to this, because we had a print map function that was a while loop and a while loop inside that while loop that was able to print out all of the numbers that are in a 2D grid. This one's a little bit interesting because it works slightly differently in that for each row it checks whether the laser is there or not. And if the laser's there, it gives us this arrow, and if it's not there, it just does some spaces. And then otherwise it goes through and prints the row of whatever numbers are in the map. So you can trust this. We've written this for you so that when you're fiddling around with how to place stones or how to delete stones with the laser and all this kind of stuff, you can trust that the print map is going to tell you what's happening in your code. So we made this so that you can see visually how things are going. Calvin is feeling a bit nervous here about having no programming experience before uni, and is this considered hard? What's the average mark and stuff like that? It's hard to say. I think a lot of people are going to come into this from different levels of experience and different levels of understanding so far of how much you've learnt of the course. If you look at the assignment and what we're asking you to do, I would say the assignment, the core of the assignment as it stands, is roughly, I don't know what you reckon, Tom. I would say about 8 lab exercises. So I would say
eight individual exercises.
Yeah, like 8 individual lab exercises. It's about that. Like, it's actually less pieces in the stages, but some of them are harder. Yeah. There's like 6 pieces, right? Is it 2 pieces per stage?
It's a little bit. Oh, so sorry. I thought you were talking in terms of how much time it would take to complete it.
Yeah.
It's sort of like.
So I was thinking that there's like 6 pieces, but they're harder than lab exercises. Some of them are harder. Some of them are easier.
Yeah.
Actually. Yeah.
Yeah. I think the way I would describe it is that the first stage is about the difficulty of 3 or 4 lab exercises put together. Stage is the same thing again, but it's sort of like harder regular lab exercises. The third stage is like easier extension lab exercises, and then the extension work is like the extension lab exercises, basically. But one of the things that you'll notice, and this is where style is so important, is that the more code you've written, the more you have to deal with the fact that there's other code going on. So it's sort of like, not only are you dealing with the harder challenges, but you're also dealing with the fact that there are more, there's more lines of code you've already written that could interact in weird ways, which is why it's so important to have good style and to have things like functions, because that makes it easier to interact with the different parts of the assignment differently, effectively.
And also, to Calvin's questions about feeling nervous, the way that this assignment is designed is it's actually designed in order. So you can safely ignore everything after stage 1 until you've completed stage 1. So if it feels like there's a lot of stuff to do, just ignore it. Like, ignore everything except for the first problem, work on the first problem, get it going. And then, after you've completed the first problem, you go, okay, now let's look at the second problem, you know? So every big project is always daunting until you figure out a way to break it down into parts. And that is a skill I'm trying to teach you, but for the moment, considering this is the first big thing we've given you, we just broke it down into parts for you. So if you do all these little parts, eventually you'll be able to create something that's, like, you know, much bigger than the sum of those little parts. But if you look at it as, I need to create the reference solution, so I need to just build it all now, then yes, that's going to be too daunting to be able to do. So I would say take it step by step, and you should be able to get there.
It's also worth noting that doing the first stage of the assignment is sort of practice for the second stage, because everything you're using in the first stage will come in handy for the second. So by the time you get to stage 2, you'll have more of an understanding of everything that you would have in stage 1, and you'll have learned more and you'll be better at it. So don't feel like, oh, I'm not going to be able to complete stage 3 now. If you get to stage 2 and you've done that, well, then you'll have sort of the requisite stuff to do stage 3 and so forth.
Yeah. And so other questions there, Rich Russian Boy is asking you about the extension tasks, and if a beginner is trying to get a high distinction on the extension tasks. We'll talk about that when we actually present the extension tasks to you, but there are actually ways that someone can score quite high marks on the extension tasks without actually understanding the programming that well. There are tricks. So this isn't just a... the extension isn't just marks for people who've done programming before. In fact, it's actually designed in such a way to try to teach you things about what's more than just writing code. You know, like, writing code to get stuff done is like, yeah, okay, sure, we need to do that, fine. But being able to test code, being able to verify that it works correctly, being able to explain your code is a much more, like, you know, proper professional computer scientist way of doing things, which is why all that stuff's in the extension thing. And yes, it is harder than the core, which is why it's separated. It's also, I would argue that it's not necessary to do, because you can get enough marks in the assignment to be like, yeah, I can pass this course easy without touching the extension work. at all. So I need to, like, this always happens, right? This always happens when people come out of high school and come to university. Because, like, you're in high school and you've got an assignment, you try to get 100% in the assignment. If you try to get 100% in everything in university, you're not going to make it. You're probably going to stress yourself out and really kind of hurt yourself. In university, on average, people should be aiming, like, if you want to do well and succeed in university, you know, get honors or something, get a good job or something, you should be aiming for a mark in the 70s in general. And that's a good way to do it, because you can conceivably get a mark in the 70s in all of your subjects if you're a high-performing student. And I'm saying a high-performing student, not an average student. So, I think, yeah. So I think that's the thing, and it always takes people a bit of time to figure out how to do this, because the high distinction is not something that everyone can aim for. I think that if we want to look at the average student in every subject and what everyone could aim for, you could aim for credits. I think you could aim to try to get a mark of 65 in all of your subjects, and if you were concentrating on everything and working reasonably well, that would be a target that would probably be possible. I obviously can't speak for all of the other subjects at the university. Some subjects are 100% harder than other subjects, and you will know because they will be like, oh, this is the advanced version of this other subject, so you better have gotten like a distinction in the first one before you even attempt the next subject, that kind of thing. So those ones, you know, you pass something like, in CSE, the famous one is Advanced Operating Systems. Like, you kind of want to get a distinction or a high distinction or something in operating systems before even thinking about advanced operating systems. And if you pass advanced operating systems, like, you don't even do that well, you just pass advanced operating systems, you're probably in the top 1% of computer scientists in the world in terms of operating systems knowledge by the time you've gone through that. So I never even did it, you know, because I was like, yeah, I don't think I can get through that. And
I mean, I dropped out of it, like,
yeah. And I got an HD in normal operating systems, and I still thought I shouldn't do that. But, you know, there's a different era and things, so I shouldn't always use that as an example. People seem to think that AOS is, like, really hard, and I probably shouldn't say that stuff too much. But yeah, so we need to kind of recalibrate that if you finished all the core for the assignment, even though that is, I think it's 80% of the total marks assigned to the assignment, that's more than enough, you know. And that's why these are separated as well. But we'll talk about the core extension thing in a second. Sorry, Tom, you're about to say something.
Yeah, the other thing I would say as well, I agree with everything that Mark just said. Also worth noting, though, that you can complete the extension with just everything that we've taught you and nothing else. Yeah. So it's not like there is some inherent advantage that you need to know something extra that we haven't taught you. There are certainly elements of the extension work where having familiarity with the things that we've taught you is useful, not in of itself just because you'll be a bit more comfortable using them, but if you spend a reasonable amount of time studying up on those concepts, if you spend time working on it, you can get 100%. It's not like we've intentionally tried to make it impossible to get 100%. But the trade-off for that will be, like, there's a lot of work to get to that 100%. And we've made it a lot of work to get to 100% because that's, you know, 100% on assignment is a big deal. So the sort of trade-off is, well, you might get 100% this assignment, but you also might, you know, get P's in your other courses or something, right? Yeah. So it's sort of this question of, well, like, if you really want to put in the effort and you really want to get 100%, that's a laudable goal. I think it's a tough goal. Like, we shouldn't understate how difficult that will be. But also, if that's what you want to do, it's possible, even for a student who's never programmed before.
Yeah. Okay, so we've only, I think we're 40 minutes in, and we're kind of up to this point here. There is actually another program that you can run, which is the arcade version of Slide, which is it up here or?
It's right at the top, I think.
It's right at the top. Oh yeah.
I might be wrong.
If you want to, this is weird because we haven't really necessarily set this up with maps to use, but there is a 1511 arcade solution here, which is this, did Dean write this, Tom?
Yeah, well, Dean mostly wrote it. He took some of the pieces from the Canvas app, but same difference, yeah.
So This is an ex-tutor who is now working for one of the big consulting firms in Sydney. Wrote this that allows you to just play one of the auto tests like it's a real-time game. It's actually a super hard real-time game, but you can see. I'll play it now, and then you'll see. Okay. Oh no. I didn't see the finished solution, but if I fire the laser there, you can see that I was able to fire the laser and shoot through some of these blocks here, but because it was shifting leftwards at a reasonable speed, I wasn't able to shoot them all before I hit the end, and then when the blocks hit the end, it says the game's lost there. So, this is the idea that the code that you're writing in the background could potentially be used to build a game like R-Type that I was playing before. And one of the interesting things about that, if I just quit out of this, is this one says 1511 arcade solution, but you can actually put your slide C file in here. So you can write 1511 arcade slide.c in the directory where your slide.c is, and it plays your game. So it uses your code as the back end for that real-time thing. So you can play it and see whether yours is working or not. I was about to do it now, but I don't think my starter code solution here will do anything. I think it'll just print an empty map every time because there's nothing in here for the scanning and the number of blocks. So, and then none of the other commands are working, so I don't think it's worth doing. But if you make a little progress into your game, you can then run it with Arcade Solution and put in some of the auto test inputs and then see how it goes. It's kind of would work, but then also kind of wouldn't, because it's really hard to test something when it's flying past at rapid speed. You can also use the reference solution to see how it performs compared to yours and look at the difference and see whether things are working or not. Minol's saying, what is the high wham for computer science? Is a mark in the 70s? I don't know. I don't look at the statistical marks for students later on in their degrees. The average mark for COMP1511 is, I think it's in the 60s somewhere. I think it's high 60s or low 70s, I think. I don't know if
it's also hard to get a WAM for 1511 because a lot of the students who come into the course don't have a WAM.
Yeah.
Or what happens is you've got a really weird WAM because you've done like you're new to uni, so it's not really representative.
Yeah.
So talking about the WAM that we get in 1511 or the mark even is really not that useful. I understand why you want to know the answer, but it's kind of a hard question to answer.
Yeah. WAMs are like super volatile in first year, right? Uh-oh. I've lost Tom. Have I lost anyone else? Is the stream still going? Oh, no, I just lost you temporarily. I reckon this is like...
Yeah, you might have lost.
I'm communicating with you, and that's using bandwidth. I'm also streaming to YouTube, that's using bandwidth, so I'm running out. It's okay. You were a little choppy earlier as well, but I think it'll be fine. I think your message is still getting through.
I think I just saw... I'm seeing myself freeze on the on the live stream now.
Okay.
Did you get what I said?
Yeah, I think we got most of it.
Cool.
Yeah.
Yeah, just like WAM is not as important as people think it is.
Yeah.
The big message.
And also it's early days. Your WAM will be volatile at the beginning, and then it'll settle out the more, like it'll average out the more courses that you do. Now, someone was asking how long this stream was going to go for. We will definitely be stopping at 6 p.m. But if we finish up and there's no more questions by then, we'll stop then as well. Am I looking... I'm not actually looking at the published version of the assignment spec right now, am I, Tom?
If you're not, can you like go to the published version? It will show the correct solution. Just get rid of the tutors.cgi bit.
Yeah. All right, so this will have the extension work, but we'll get into that in a second. Okay, so we're going to talk about how you actually start working on the assignment. So we've actually gotten to this, right? We did the setting up and the starter code, so we've copied that across. We also need to know how we're going to submit this assignment. Oh, mac and cheese, you have to go to a lab. I'm sorry. Yeah, so that was the thing about this live stream, is that I had to find a point where there was the minimum number of people who are going to be affected by it. So this is a time where there's less conflicts, but also both optional and recorded, so you'll be able to check it out later. Okay, so your submission, if we go through, I think, is it in assessments? Yeah, here we have the submission where we'll be using a command in our Linux systems, so you can do it via VLab or if you're using SSH. However you're working on our stuff, as long as you've got somewhere where you've been able to run auto tests and things, this will run in the same place. Give CS1511, so it's like you saying, hi COMP1511, I'd like to give you something, and the thing I want to give you is my assignment 1 slide, and then the last thing is the most important thing, is your actual C file. So when you do your submission like this, it's a very nice thing to do, because what it does is it makes sure that your code is saved on our systems, so that anything goes wrong, you will always be able to retrieve any previous submissions you've made. This is a really safe way of doing things, because if you're just working on your home computer and you press save, then your code is kind of at risk, because anything happens to your physical computer and you're going to lose your code. Whereas if you submit your code, it means that we've got it on our servers, which are backed up. So it's a much safer way of saving. And I'm happy for people to even treat it like that, where you just go, this is just saved, right? So every day that I work on the assignment, every few hours, I'm just going to submit it. It's like, even if it doesn't compile, it doesn't matter. You're just going to submit it. And it means that your code is kind of safe. So I'm more than happy for people to submit multiple times. We're just going to look at your final submission before the due date, basically. Or actually, if you really want to submit after the due date, we will mark that as well. But you have late.
There is a late penalty.
Yeah.
So also worth noting, auto test will also back up your submissions.
Yeah. So anytime you auto test, there'll be a save, and you can actually go into, on the course website, you can go into your student page there, and you can actually download the code that you've auto-tested previously there. So it'll be pretty good. So if you're like auto-testing, things are working well and stuff like that, and then you have some wild ideas, and then you change a whole bunch of your code, and then suddenly it's failing all these auto-tests, you say, oh, I really want to roll back to where I knew it was working. You can always go into your student page on the class website, find that previous one that was passing more auto tests, and go, all right, I'm going to copy this back in, look at the two of them, and go, all right, I want to take the good bits out of both of these. A lot of stuff like that. So you don't have to work with only the one most recent version of the assignment. You can use our systems to just keep backing stuff up. Yeah, Jeffrey was asking, yeah. Oh yeah, you were asking as I was saying, yeah. Your last submission will be marked. Swathi Shan is asking about, can I explain scan commands until EOF? So, best place to look for these is the demo code that I put in the last lecture. So I did some scanf demo code, which should be here actually. Lecture 7. Scanf demo. So when we say scan commands until EOF, that's going to be, I'll go to this one is the easiest to understand. This was something that was going to scan either 10 numbers, or it was just going to keep looping using this sentinel variable up until scanf gave us a result that was not equal to 1. So this was scanning in a single number at a time, and then at any point where it did not receive a one number per time it tried to loop, it would say there's an issue here because we didn't scan something in, and we'll end the loop. This is exactly what we mean by scan until EOF. EOF is actually the thing that basically gets sent into the system if you press Control D. So this kind of code is the kind of thing we mean, and you can basically do it this way if you want. You can keep scanning in until something is not the right number that you've scanned in. You can't just use this code as it is. I mean, obviously I'm not going to solve the assignment for you, because you need to know, based on the input that you're taking in, how many numbers you should have. So, simple example of that. Where's my, not arcade, the slide reference here. If I say how many blocks, and I say there are 2 blocks, Now I know for sure, because each block is represented by 3 numbers, I know 100% certain that I now need to read 6 integers in exactly. So I could do something like this that says loop until you receive 6 integers, or until something else goes wrong. So that's actually a simpler example here, because you really only need to do exactly the right number. So let's just put some blocks in, but now we have this open command thing. So if I want to move the laser, so I think it's just 1, 1, we'll move the laser down. Is it 1, -1, or is it 1, 2 that moves
1 moves it down, 1, -1 moves it up.
Yeah, so that's actually changing the row coordinate of the laser by exactly that value. So you can see that, oh, I can even space them out like that, it'll still work. The laser is just moving up and down based on the inputs that I'm putting in, and I could conceivably do this forever. So if I wanted to, I could just keep putting these commands in and just keep going. Like, there's nothing that's stopping my program. But at this point, if I press Control D is here, is like it said explicitly, is this way of saying I'm going to give something, in a sense, to scanf that is empty, and that is that EOF thing. So what we're going to get is this won't read a number in when I press Control D then, and so this says the result is not 1, we will not keep looping, and then we exit that input loop. And we did that here, and in slide that means that there is no more input for running this game, so the game will end at this point. So that's going to be the idea of scan commands in until there are no more commands, and the no more commands is going to be specifically like that Control D, which is also thought of as EOF. So I went through a little bit and I talked a little bit more about these and how to use them in the lecture, so that's probably not a bad thing to go back to. Also, your tutorials and labs this week will have some of this stuff as well. Jeffrey is asking, are the auto tests extensive enough to check everything, or will we need to do that ourselves? Well, this is always an interesting question. The auto tests can give you a lot of really useful clues. So they can tell you a lot of things, saying, okay, here's the basic functionality of this thing, and whether some things that you've done work or not. Let me give you an example of what may or may not be in auto tests and how you can think about them. So we've got this grid here. Actually, let's use this one. We've got this grid here, and we might auto test you by placing a few stones. So let me say I want to place a stone at 1, 1, and it's a normal stone type. And then I will place a stone at 2, 4, 1. And then you'll have to be like, that's a stone that's outside the grid. So if it's outside the grid, then I have to make sure that I don't just blindly try to write a number into the array at 2, 4, because this particular one is smaller, right? So this one only has size 4, not the full size 15. But this is invalid, and we need to be able to just look at that and say, that's invalid. We're not going to try to write a 1, because 2, 4, 1 is here. So if I tried to write that thing in 2, 4, then I would probably cause the program to crash if I blindly tried to write in there. So what I need to be able to do is identify that this is incorrect and say, do not create that stone. In an auto test, we might give you this in the auto test, which tests things going off this right-hand side here. We may not give you auto tests testing that are off the top, the left, and the bottom. We might only test one side. But what that auto test should tell you is, I don't know if this is exactly an auto test, Tom, because I'm making this up, but I'm sure there's something like this. What this should tell you is that you need to deal with these invalid values and just say, if someone gives me an invalid value, it just doesn't go on the map, right? But what we may not do is bother to test you on all the other sides of the grid in the auto test, because we've already shown you that off the grid is something you need to deal with, and you're going to need to make sure that you've got code that tests against the top, left, and the bottom, because when we're doing the marking, then we're going to test everything. Well, not everything. we will test a lot more stuff in the marking to make sure that you've got the right idea from what you should have learnt from this auto test, which is like off the grid means you should have some kind of behavior to deal with that, right? So that's an example there of how we might use an auto test to show you a situation that you need to deal with, but then when you see that test, you might think, what are the other ramifications of that situation? Are there other things that could cause problems that are similar to this that I might need to deal with? And then you might even start writing your own tests, because you might be like, okay, this auto test I can see is incomplete. I can see they're only testing one side of this. I'm going to write my own test for testing the top, bottom, left, and right, and then I know I'll be pretty safe if I've got all of them covered. So that's an example of how...
Can I...
Oh, yeah, go for it, Tom.
Yeah. The way I generally like to think of it is that when we're writing the regular tests for like the regular stages 1 to 3, we're not trying to mess with you. We're not intentionally like trying to leave stuff out. It might be that we don't test some very specific case that messes with you, but we're not trying to like intentionally leave a large chunk untested. Whereas for the extension, which admittedly we'll get to later, there are intentionally cases where we're like, we know that this is something we say, but we're not going to test it because you have to go find it yourself.
Yeah. Okay, so we have talked about submission, and we have talked about auto tests and marking tests and the difference. That was actually really interesting because like Jeffrey there in the chat is the one that actually pushed us to this next line in our agenda. So Jeffrey, you're now the chair of the live stream because you're the one helping us move through into the things that we're supposed to be doing, which was great. Okay, so now let's look at the extension reveal. So what we've seen... roll. And yeah, what we've seen and what people have been looking at so far is the first 3 stages. And so some people, I think, he's behind you. You've hacked my Google Docs and you're reading these notes in my Google Docs already. So the first 3 stages, people may have already even started working on some of these, if people are super keen, or if not, they've been reading through these just to get an idea about what kind of work is in them. But the extension work, we hadn't released yet, and now we have, and the extension work. So what we've got here is the idea that we expect students to be able to do a significant amount of the core of the assignment. Because the core of the assignment, what it's testing is your capability of working with arrays and while loops and if statements and things like that. So this is what I consider core competency. These are the important things that you must be able to do to be kind of happy with these topics in the future. So if you've done all 3 stages is actually a lot. By the way, all 3 stages is getting to, successful student, like very successful student, because that's going to get you a mark close to like 80 if you complete all 3 of them. That gets you the kind of rubber stamp of approval that Mark has said, if you've gone through all this and understood all this, then I don't need to teach you about arrays anymore. Like at this point, you've learnt enough to be able to go on to learn from someone else about more advanced versions of these topics, or even reach a point where you could just probably teach yourself everything from there on. You could understand it with minimal effort. So that's what I would say about someone that's completed the core of the assignment. The extension work on the assignment is if someone says, all right, I've got the core competency and I'm confident that I have more time and I want to spend more time on the assignment. I want to see how much further this goes. So the extension work is now teaching you different things. Yes, it has difficult coding in it, but we're now getting into a little bit of teaching lessons that I guess what I would say is they're a little further in the future. These lessons, you won't see the need for them until further in the future than the core work. The core work, you can see it right now. You go, I need to do this because this is important for like understanding how to do coding, But the extension work is this deeper level of like, okay, if you do understand the core of coding, can you understand these extra bits, which are, can I work in a programming team? Can I work with a specification that is incomplete? Can I work if if all I have is a vague idea of the behavior, you know? So these are the things that we're doing. And also, can I potentially not even write the code to solve the problem, but can I write a good set of tests that check whether this problem works or not? So that's that kind of thing that's in the extension work here. So we've put in a lot of stuff here to be really clear on the crossover between the core and the extension. And these are things you can use to answer the question for yourself. The question being, should I do the extension work or not? So there's questions here that say, these are the things you probably should have. Actually, this is not probably should. These are like, if you haven't done these things, then you shouldn't go for the extension work. So, do you understand functions well enough to go deep into the extension work? So this is like a technical thing. Have you written functions yourself in the core of the assignment? So do you have a really strong kind of grasp of the latest topic that we've been working on? And can you do good functions that aren't too big, but that have each one has like its kind of, I want to say core functionality, but I'm just using the same words over and over, right? Each function does its thing that it's supposed to do, and then you understand that, then you can move on to the advanced stuff. Is your code styled well enough? Because if it's not styled well enough, it's not passing 1511 style, and you haven't kind of been sure that your code's already very readable, there's no point you going into the extension stuff. There's more marks to be earned by just fixing up the style in your current work. And then we have other questions here, which are things for you to think about. We're not going to enforce anything like this, but are your labs already complete? Are you on top of things there? Are you on top of what's happening with your other uni work? So, the way to kind of think about this, the 80% of the assignment, that is stages 1, 2, and 3, and the style marks for the assignment, is roughly the same amount of work as the 20% of the marks in the extension. I don't know if you'd think the same thing, Tom. I actually think potentially the extension work it would take more time than the first 3 stages, depending on where you're at and how prepared you are for this. Which is why this thing is full of warnings saying, and this is how, like, we're just being more open about it, I think, than other subjects. We'll just give you the whole assignment and throw in some really difficult things that will take, days and weeks to do. What we tried to do, this is actually the first time we've done this, we split it up like this, because we didn't want everyone to think that they had to do the stuff that's in the extension, so that's why we split it up now to let people know that the extension work is specifically not an efficient way to get marks. It's there if you really want to do it, you really want to push, or you're really happy with how you've completed the first stages, and you've already proven that you understand everything you need to for the assignment. Now you want to go deeper, right? Yeah.
Can I say 2 other things quickly? Hopefully I'm not breaking up too much. The first thing to say is that, like, we're hoping also that the extensions are kind of fun. Like, if you are not enjoying yourself and you are just like, this is awful, why am I doing this? You don't need to do the extensions. Don't force yourself to do it if you don't want to. This is for the people who did the stages 1 to 3 and are like, oh my God, I want to do more. I'm loving this. And for those people, the extensions are designed to hopefully be helpful and to teach you useful things, but don't feel like you have to. The second thing to say as well, just on the 5 sort of instructions about, like, you should have done this first, those are not just because we're evil people who want to prevent you from doing the extension. That's also because you will not be able to do the extension if you have one main function that is 700 lines long. Trust me, it won't work.
It's really hard to actually get it going then, yeah.
So, like, you will save yourself work, even if you do want to do the extensions. Make sure that you have done the other stuff first, because otherwise you will not have a good time. If any of you have seen that, like, South Park meme, I know it's like a really old one, but, like, if you're going to do that, you won't have a good time.
Yeah. Okay, so given that, so our preamble for the extension is part warning and also part this is a fun bit. So for some people, this is the fun bit, but for some people, this is also like it may not be worth your time. So you decide. We have a reputation that I'm trying to get us out of causing people to fail other subjects because they get too deep into the programming things, and I really don't want people to just be failing their other subjects at uni because they get too caught up in the hard bit of our assignment, which was really worth only like it was worth like a rounding error's worth of marks by the time you finish the term in 1511, right? So it's not something I want people to like burn themselves out over, unless they enjoy it, in which case, do what you like. Like, if this assignment gets you, I'm using a stereotype here, but I think it might apply. If you don't play any games for the next 3 weeks and do this assignment instead because you enjoy it, then my work is complete. That's if you're someone who did play games heaps otherwise, which I think a lot of us are. Alright, so let's have a look at what happens in the extension work and what kind of work you need to do for it. So the first thing you need to do is you need to actually separate your extension work from your core work. So we've got some suggestions here saying you need to first grab the documentation file, which is something that has a template in it that you'll have to submit. So let's actually do this. Let's grab this one. I will have to go back to my assignment 1 directory there, and I will paste that command. And so this will copy this in here. Let's have a look at it. So here we have a template to make it easier for you to write your submission. So it's like, okay, here's the summary, here are the tests that have been created, and here's the other one. So there are 2 extension exercises, and each one of them, let me go back to the assignment spec, is going to ask you to write some information. So we're going to ask you to actually communicate the way that we would be communicating in a working software team, which is that we don't just write code and throw it at other people. We write code and we write some information about what it does and how to use it and things like that. So we're asking people to write that. It's not much. This is not going to be like an English assignment or something in high school. It's only 100 words. So this is a long comment, if anything, that just says, okay, this is what this thing does. And then we're asking you to actually write some tests. So the only thing you need to do for these tests here is write a series of inputs. So in the same way that I've been doing stuff here, which is like, that was a whole series of 1s and 0s. I was showing that it looped forever. So I could do this, where it's like the inputs is like how many blocks, the blocks, and then these commands, and you can just put them line by line like that. And so you can put the test in there, and then you can make a test which you think shows whether or not this extension thing that you may or may not even have created is working or not. So if you want to, you can actually submit this with only the testing and get some marks for this, even without having implemented that. Oh no, you have to. Oh no, you have to implement it.
You have to pass the qualifying tests before.
You have to qualify at least, which means you have to get the basic auto test pass to do this.
Correct.
Yeah.
By the way, in case you're wondering, is just because like if we had 1,800 tests and we had to run them against 900 submissions, we effectively have a supercomputer here at CSE, but even that would take too long.
Yeah.
So that's why, and also because we might talk about this later when we get into like how it's marked, but there's peculiarities in how it's marked that means it's easier that way. Cool.
So let's have a look. Actually, I should do this in order that's here. So let's look at the... and so we would also have a copy like this. So we would be submitting a different file that starts off the same as our first 3 stages finished slide.c, and goes into the slide extension.c, which is the thing that we will then be adding to and things. So if you're going to work on the extension, you'll submit the extension using... Where is the submission? I know it's this.
So there's no current submission instructions because I haven't published that yet.
Because we haven't fixed it. Yeah. We haven't got that working yet. So there's this. Yeah, don't worry.
I mean, of course it's working. We intentionally decided not to release it till Saturday because we've got it already, but we just decided, let's make it a bit later.
Okay.
Being sarcastic.
Yeah. So yeah, there's no submission instructions yet. So they will come out soon.
I mean, I can tell you that the submission instructions will be like 1511 auto test slide extension or slide ext.
Give CS 1511. Yeah, it'll be probably the same command, but we'll let you know what it is when it's actually ready to accept. If anyone's ready to submit the extensions by Friday, Saturday, then maybe you should chill out a little bit and not work so fast, because there's other things that maybe you should be doing. Maybe you forgot to sleep or something like that. Okay, so that's the documentation and there. But we should look at the... where is it? The qualification stage. So this is the idea that you do need to actually get the basics done on the extensions before you start actually testing other people's code and stuff like that, which we're actually going to do. So you have to write what you did to make it work. You have to have written your 2 test cases at least, and this is all in the documents file. And then you also need to write your code, which is in the slide extension.c file. And then you have to pass these qualification tests, which are basically auto tests. They're not complete, they don't test everything, but they test enough to make sure you've got the basic functionality going. So once everyone who's got the basic functionality going has submitted, this will be after the due date, we will then go into these testing stages. So after the due date here, we will look at all of the tests people have submitted in their documentation files, and we'll see which of these are kind of testing the right things or testing interesting or useful things, and all of those are then going to be, well, not all, some of those are then going to be run on other people's assignments. And so I'm not sure how open we're going to be, Tom, with the statistics for this, but we might actually be showing some information about what some of those tests were and what the percentage of assignments did or didn't pass those tests. So you might be...
So...
Oh,
yeah. So the plan as of right now is it will depend somewhat on how many people submit, because we can't we can't run 900 submissions against 900 other submissions. That's if any of you know how n-squared problems work, it's a difficult problem. But basically, you'll see how your tests did against a subset of other people, and you'll also see sort of the overall percentage of other people's tests that you passed, or an approximation of that percentage. So yeah, I think that's the main thing to say. I don't think you'll see each individual test, but if there's a concern about a test, we can certainly look into. But you'll just see the overall statistics on how you went against all the tests together.
Yeah. We had a question there from Zach about globally defining a variable. You will definitely lose marks if you globally define a variable. That's a serious issue that opens up very big potential flaws in programs if there are globally defined variables in it. So I think you should be able to find another way to track whether the game is currently being won or lost or things, just by putting a variable inside your main function and having it work with that variable, and then only passing that variable to functions that specifically need it. Because if you have a global variable, this is something I don't even teach, right? So other people, if you don't know what a global variable is, don't worry. It's something that is it's kind of old school programming that we try not to do anymore, because that variable is inherently unsafe. Because any variable that's global can be used from anywhere in the program without any kind of protection, which means that you could mistakenly change it in a function that was never meant to have access to it. Whereas if you put it as a variable in your main and you say any function that needs this is going to get given this variable, then that changes things, and it's much easier to see where it went and see who has access to it and who doesn't, and things like that. It's much safer. So yeah, so Zach, be careful of that. There will be another way around it, and this might actually be a decent one to talk to a help session or your tutor about it, and just go, look, I tried to do this thing and I think I need it, but Mark said there's got to be another way around this. But if you can't see exactly how, you might be able to get some help with that kind of thing. So these are the things, especially if you're early, you're thinking about this now, you can go to help sessions now and just stroll in and talk to a tutor. If you go to help sessions during the flexibility week, which is the last week that people are working on the assignment, they're going to be super busy, right? And there's going to be long queues and stuff at that time. So that's the kind of thing where asking you help about that stuff now is a good time to do it. Okay, so we're talking a little bit more about the extensions. So we've got the testing, which is going to be testing against other people, and then there's going to be this evaluation stage, which is you have tests run against all the different qualified submissions, and even if you didn't get full marks, like you failed some of the tests that other people wrote and stuff, if your tests are good enough to catch out a lot of other people, you will earn some marks there as well. So this is actually this is part of the profession of computer science. There are people working in computer science who don't write code, they write tests, and they're specialists at breaking all of the systems that other computer scientists build. I don't know if everyone's heard of QA, quality assurance testing and stuff. There are QA engineers. People are there who look at what something should be and what it is, and they try to find the differences for us. So they say, this is what it was supposed to be when you started building. This is the thing you built, and I can poke a hole here, here, and here, and then the whole program falls apart. And those of us who, I've worked more as a coder than as a tester, but in those situations, you're like, oh my god, thank you so much. Because the only other place where that would have been a problem is we would have just released this thing, and then a user would have done that by accident, and then our whole thing would have fallen over, and the company's reputation goes down the tubes, and it could have been prevented by someone just, really thinking about their testing. And so this is something that we're doing here, which is okay, can you write tests that are good enough to really, really pick at whether at the kind of mistakes that people maybe aren't thinking about when they're first building this thing, and this helps people build better software. So this is where you can get marks by that. We haven't got the full assessment marks breakdown for how the testing marks gives you marks yet, do we, Tom? I don't think we do, right? Oh, wait. I'm asking the Tom who is... Oh, wait.
Sorry, I just dropped out.
Yes, you're back.
I dropped out for a second there.
Did you...
can you repeat what you just said? I'm sorry.
I was just saying, we don't have the exact criteria for how the peer testing and the testing phase is going to earn the marks yet, do we?
No. So it'll be based on the statistics of how people submit, such that,
it's going to be complicated, though.
Yeah. It'll be somewhat complicated because it depends on if loads of people submit tests that break loads of other people's code, we'll have to mark it.
Yeah. Okay. I apologize. This is going to be my connection, just trying to go back and forth with upstream to YouTube and back and forth upstream and downstream to
marking. So it's. Oh.
Yep. Sorry, you froze. So it's okay. It's okay. I think the idea is there. More information about the marking will be coming later. So. Let's have a look at the two extension questions. So one of them, I don't know if it's your fault, Tom. I would have assumed it's my connection. It'll be my upstream.
No, it's definitely my fault.
Oh, it's yours. Okay.
It's my fault because I can see the streams freeze at the same time.
Oh,
and I'm just like, oh no.
At the same time. Okay. Yeah. That's awkward because
he
has
want
a very good internet connection.
You're welcome to blame it to you.
Say again, sorry?
Yes.
Yeah.
I was just saying, if you want to blame it on you, you're welcome to.
Oh, I'm not taking the blame anymore, now that you know it's you. Okay, so, two things. I'm not going to talk too much about these, because I haven't even talked about too much about the specifics that are in these three stages here. But there are two things. One of them is this double zone thing, where there are blocks that appear in the nighttime and blocks that appear in the daytime, and then they will appear at different times, based on... flipping back and forth every time the user shifts left. So this is a pretty common game thing as well. I think some Mario games have this where you can't see things sometimes and they flip in and out between this day and night phase. So you have to implement the idea that there's kind of two possible worlds and they're both going to be working at the same time. The other one is the mirror blocks. So instead of being normal stone blocks, these are reflective blocks where when the laser hits them, it's going to split and it's going to go up and down from the position of the block that it hit. And it's potentially going to break other blocks above and below it. And they're going to have a certain amount of... when we break blocks with the laser, it's kind of the laser has enough strength to break 4 blocks, and the mirror blocks is going to have whatever strength is remaining when it hits the mirror block hit other things. So more complicated ideas than the initial stages. Not super more complicated than something like the TNT blocks, actually. I'd say the TNT blocks is a similar level of complication. But the trick, that the complication in the extension work is the extra complication of saying, we didn't give you complete and adequate auto tests for these. We need you to write tests yourselves, and we need you to think about the way that you might be tested as well by other students. So knowing that you have... I'm thinking of... I don't know how many people are going to go deep on the extension work, but I don't know. I'd say maybe a quarter of the class or half the class are going to go into the extension work. And you've got to think about those people and like, how are they going to test my code? It's like, can I write it so it's like really, really clear and always correct for everything for both the Night Realm and the mirror blocks so that I can pass all these tests? And also, do I have some good tests to write that are going to be useful for these kinds of things? So I think that's everything that I wanted to... Oh, yeah, sorry, Tom.
Can I jump in with a few things? Would you mind going, rather than focusing on me, can you go back and find right above the mirror block section, there's a sample of what you're supposed to submit in slide docs.txt.
Yeah, this is good. Yep.
I just want to really quickly outline for everyone how this works. This format is particular. If you remove any of the like curly braces, it will actually break and it won't accept your submission. So you need to be careful that you're actually keeping this submission, because we need to like programmatically look through your file, and we can only do that if it's arranged like this. So please only just change within those 3 curly brackets. So the summary, I think we've already explained that. With the tests though, worth noting 2 things. First of all, those tests, we first of all check them against the reference solution. So if they cause the reference solution to either crash or to say this is not being tested, they won't be accepted as valid tests. Once we've tested them against the reference solution, we also then test them against the both your solution and the reference solution at the same time. And if your solution produces a different output to the reference solution, they won't be considered valid tests. So basically, you need to make sure that these tests cause your output to be the same as the reference solution, and for it not to be an error. That's sort of the way that this is going to work. And then within that, you also want to be trying to, as much as possible, find test cases that you think other people aren't going to have thought about. Because the less that other people have thought about your test case, the more marks that you can get from that test, basically. So it's almost like a competition of, can you find the weird edge case that nobody else has thought of, which makes it extra fun, I hope.
Yeah, that's cool. I'm glad that we've got this example in here. Obviously, if you copy paste this code in here, this text in here, then there will be problems. So you have to write your own.
Yes. Again, also, like, that summary will be useful to you. Like, we're not just making you do it because we're cruel gods. I mean, Mark might be, but I'm certainly...
I'm a cruel and vengeful god, yes.
Right, yeah. We're making this because when you go into a programming job, one of the things that they'll make you do is what's called a pull request, which is where you've made some changes to your code. You have to describe it so that somebody else can read your code and say, yes, this makes sense, that I understand what this is doing. If you can't write like a 200-word summary of like, here's what I've changed in this code, then your pull request won't get accepted. So this is quite literally like a skill that you will need to develop for working in industry. So it's a good time to practice that skill. And also the way that I formatted it, so I've sort of referenced line numbers and I've said this function needed to change. That's probably a good thing to be thinking about when you're writing it. Like, think about what regions of the code you had to change, how you had to change it. You don't need to give like an exact description of every single change, but sort of highlighting the areas that you've changed is sort of what's going to really make it a useful summary.
Yep. Okay. I think that's everything that we needed to talk about the extension. So if you're looking into the extension, hopefully that's enough information to get started. If not, there's always the documentation. And if we've made any errors in the documentation, I think... Who pointed that out? Anders has already
Mark,
pointed
that was never
out.
there. You might want to just refresh the page. I can't see anything.
Oh, sorry, that was never there. Let me just refresh the page. Oh, wait, where is it?
I don't know what you're talking about.
I don't know where I was now. Mirror blocks. Oh, see, that was always fine. I just hadn't refreshed the page.
Yeah.
So you're
No,
just watching us
there was
real
never
time,
any issues.
real time fixing issues. Does Anders get an achievement for that, Tom? I don't know if we have achievements for finding.
We haven't set them up yet. I'll set them up later, but there are a few people on my list who are going to get the achievement for that. Yes.
Ah, okay. So whenever that comes up, there will be potentially an achievement for helping out with the assignment spec. Anders can get that achievement now because you found something. It's a pretty minor thing, but you did technically find something. Okay.
No, well done.
So, talking about the extension, we talked about whether you should do it and what work is involved and stuff. And so now, talk about marking. So people, I think always when we look at an assignment, want to know what the marks breakdown is for the assignment, how many marks are in each part of the assignment, that kind of thing. So you'll notice that in the stages themselves, we don't say like really specific marks breakdown of like out of 100% how much is each of these stages worth, because it's kind of like completion of each stage is never a complete thing. It's always like a kind of a partial thing. You could pass some tests but not others and things like that. So talking about assessment, there's a lot of details here. Just going to be careful about if you're using code that's not your own. We do say that you can use general purpose code from places like Stack Overflow, but you have to attribute it. So you have to put a comment in there saying, look, this is where I got this from. If I learned something from outside the course, this is the information, you know. If you use stuff that's available elsewhere and you don't credit it, then there's an issue there, because it's kind of like you're passing off someone else's work as your own. So just be careful with that. That's the only like fiddly thing here with the attribution. But just be really careful also. Do not show any other students your code, and do not look at anyone else's code. The line that I like to draw is even if we're talking to other students about the topics we're learning, when the conversation crosses over into specifically how to solve problems in the assignment, that's probably where you want to pull out of that conversation and go, no, I need to do this myself. Jeffrey, you're asking if the comment is just a link to where it is. Yeah, that's pretty much fine. Like, I would put more than just a link. I would say something like, you know, the next 4 lines of code are based on a solution to a different problem that was posted at this link, you know? So then it can be like, yeah, so I read up on these things, and people were solving a similar but not the same problem with this code. I used some of it and modified it. You know, when you put that kind of comment in there like that, we're like, okay, good, that's fine. That's showing that this person is able to use online resources and adapt them to their own needs. If we go through to the link and the link is you asking how to solve the assignment and someone solving it for you, then there's a problem, right? But that's a very different problem, yeah? So that's why we want to know if you're going to use stuff online like that. Okay. So,
Can I jump in on that very, very quickly? In week 1, you all would have written a reflection that would have detailed some resources that you have to get help, and also would have detailed the approaches that you would have taken where you really stressed about this assignment, you didn't have time to complete it. On that list was hopefully coming and talking to the course. If you are in the position where you can't complete, you're super stressed about it, or you're like, there's no way I'm going to do this, I need to plagiarize, come and talk to us, email the course. Like we can help. What we don't want to have happen is for us to realize after the term is over, you've actually copied your code from somebody else, and now we need to like drag you back into a plagiarism investigation and this sort of stuff. So there is lots of help available. In the last resort, just email cs1511@csc.unsw.edu.au. We can help you, so please just do that. Yeah.
It's a long-standing thing for this course. Is like, if you feel like things aren't coming together, let us know. And also because a lot of our kind of one-on-one help resources are stretched thin around assignment submission times. If we need to give you an extension so that we can give you help so that you can get your assignment done, we'll do that kind of thing, right? We would much prefer doing that, and I will pay tutors extra to work one-on-one with students who are in trouble, rather than having to chase people for cheating later, because I much prefer getting my tutors to help people than having to chase people who are cheating. That's much worse work for me. I hate having to do that, right? So I would prefer bending over backwards to give people a shot at surviving, than having to it's a pretty horrible thing to have to kick people out of the uni and stuff like that, which can happen.
Yeah.
Okay, so that's just the submission stuff, but we're going to talk a little bit about marks breakdown. So, as we probably saw from the course outline and the first lecture, I can't remember if we actually put this in the intro video as well. I don't think we were that specific in the intro video, but this assignment is worth 15% of your final mark. The 2 assignments together are worth 40%. Am I right, Tom? I think it's 40% of the final mark.
I believe that's correct.
I think it's 40.
I think it's definitely not 40. It's either 40 or 35, but I think it's 40.
Yeah. So, but this one, this one is definitely 15%. So the second assignment's harder than the first, so it's going to be worth more marks. We separate that 15% into the core and the extension. So the core marks are this 65% and 15% of the basic marks of the assignment. 65% are for performance, and 15% of the marks are for readability and code style. So the thing that you should look at here is 50% for performance, 65% for performance. So people might be thinking about, what do I need to do to pass this? Like, what do I need to do to get the minimum necessary? And it's okay to be thinking about that sometimes. We're going to look at the other levels. But if you're looking to get a minimum passing mark for this course, then you're probably looking at getting some of the marks for style, and then some of the marks for performance. Hello. Sorry, little friend. Can you say hi?
Hello, chicken. I would die for you, chicken.
She was just scratching the back of my chair then to say hello. Yeah, so note that you can get what is a credit level for the performance, 65% of the marks from this assignment. Well, it's actually 65% of that 80%. So it's like we're like multiplying things.
These numbers are a little bit weird. I had to do some math to get it to work out correctly. Yeah, but if you you want to say it, Mark?
Yeah, you go, Tom. You can talk for a bit.
Sure. If you get 65%, so if you get all of stage 1 and you have reasonable style, you will pass. That's if you want to pass the assignment, and passing the assignment is sort of a reasonable indication that you're on track to pass the course, then pass stage 1, get all of the auto tests of stage 1, and also have reasonable style. That's how you do it.
So I think it's important to look at this, right? If you're struggling and you think, this is too hard, I'm not sure what I can even do with this, this is the only thing that's important to you, stage 1. It's the only thing you have to do. You could ignore all of the rest of this and go, I'm just going to get a good stage 1 going, and I'm going to look at my style and make sure my style is correct, and passing 1511 style and what I think is readable. You can even actually talk to your tutor about this, because your tutors are allowed to look at your code, and you can say, look, tutor, could you please just scan this and see if there's anything weird going on with style? And they can probably spend like a minute or two looking at it and just say, well, I can understand these bits, but this bit here, you've got 30 lines of code and no comments, and I can't really tell what's going on there, or something. And then you'll be like, all right, I just need to clean up that bit, and then you'll get more star marks by the time it gets marked. But that's important to know, that if you're looking at passing the course, stage 1 actually has everything that we consider to be the core, really, really core competency, the minimum necessary competency to be okay with this. So that's interesting, that you don't really need to go too deep into the other stages, and the higher a stage is, the further the stage is away from stage 1, the less marks it's worth. So when you think about it, stage 1 is worth it's more than half the marks in the assignment, and then stages 2 and 3 are worth about 10% of the marks overall in the assignment, and then the extension work, each of those is only worth 10% of the marks in the assignment as well, and they're all a fair bit more work. So this is really kind of front loaded for us to say to you, we want you to do the important bits at the beginning. We want you to get the foundational skills, and then if you want to show off, then you go deeper. It's like that. Jeffrey's asking an interesting question. If we submit close to the due date, and then again a few hours after the due date, is your submission going to be considered late? We will mark the final thing that you submit. If you do, and I've had a student do this by accident, where they they went through and they were like kind of stuffing around with the assignment after they'd finished it, and then they submitted something like 4 days after the assignment deadline, which basically put them at a late penalty to get 0 for the assignment. If you do make a mistake like that or something, just email us. You can email us and go, I've made a big bad, I apologize, I accidentally submitted again so far after the late penalty that I'm going to get 0. Can you please mark the submission that was before the due date instead? We'll be like, yeah, cool, we can just change our system to mark the correct submission. So if you do make a mistake, then you can just pick one. So long as, like, we haven't actually gone through and done the marking yet, but you should have plenty of time, because we won't do the marking until, like, we'll start the marking usually at least a week after the due date. So you've got some time then, well after the late penalties have gone all the way to 0, for you to be like, oh, I really shouldn't have done that extra submission. I should just ask them to mark my final submission before the due date, right? So you can do that if you need. Alex is asking about variable names. Style guide's sometimes too strict on variable names. Alex, that depends on what you mean by too strict on variable names. Are you talking about 1511 style doing that? Or?
So there is a currently, I might just note, there is a currently known bug. If you try and name an array, I think that the arrays are they get slightly mad when you try and do that.
Yeah.
Don't worry, I'm fixing that. Like, that's on my list of things to fix tonight.
So our
it's just because...
our automated systems are always going to be weird, because they're never really going to know what's good or not for variable names. Follow the rules that I taught you in the lectures. Does it explain what the variable does, and does it distinguish it from other variables? If someone who was reasonably well trained in programming was to look at that, not knowing anything else about your code, and be able to say, I think that variable would be used for such and such, and be correct, then you've named it well. So put it through that filter, and then see if it comes up right, and then you should be okay, right? So some of our variable names, like row and col, like even not saying the full word column, just COL, but when it's paired up with row all the time, you kind of know that those are the row and column coordinates. Those make sense to us. If everything that you're doing, so if you used your row and columns and you rename them to like O and P or something, then you've got a problem. Because, like, what the hell is O and what the hell is P? I don't understand that, right? So you can be the judge, kind of whether your variable names are working or not. And if our automated systems are arguing with you over some of those things, that's not always going to be a problem. Best thing you can do if 1511 style is having issues with your variables is talk to your tutor about it. Because sometimes that will need to be fed back to us, and we'll have to change the style program, because, it's not an AI, it's a pretty basic system. It's not really necessarily...
It's a bunch of if statements.
Yeah, it's a bunch of if statements.
Like, our style system is a bunch of if statements.
Yeah. So it's not something where you'd want to use it as the god of variable naming. Yeah. So other people talking about variables, I think I and J are reasonable for iterators. Because that's an industry standard that I is shorthand for iterator. So, I mean, I've been doing that in the lectures, so you know that's okay. That I for a while loop iterator is fine. If you're going to be iterating...
So if you can... Oh,
sorry. Yeah, I was going to say...
I think we're about to say the same thing.
Yeah, we're totally about to say the same thing. If you're going to iterate over something that has a meaning, then probably have a meaning. So if you're iterating over rows, then use row. Like it's just more clear what's going on there. I'm not sure if that's what you're about to say, Tom.
That wasn't what I was about to say. Yes.
Yeah. Oh, interesting. Anders has found something. The reference for night mode is not printing out the map after winning. So there's...
Yes, I'm furiously looking into that as we speak.
Right.
Yes, there's a... So there's a backstory to this. Yes, we're looking into it. We will have an answer for you in the next few hours. So we'll make sure that behavior is correct before anything changes. And we'll make sure that there are plenty of tests to make sure that when you submit, if there's something like that, we'll make sure that you do it the right way and you get an error.
Anders is doubling down now. Anders has now got the possible bug in assignment specification achievement twice in one day, in 1 hour.
I'm not sure we can award it like prestige, but maybe. I'll look into it.
We'll find a way. Okay.
We'll find a way.
So
thank you, Anders, by the way.
So if we're looking at the higher levels of marks, if you're looking to get a credit or a distinction, so these are the marks for 65% or 75% of it, you can do all of these with the first 3 stages of the assignment, so your mark can get up to 80 in the first 3 stages of the assignment. In order to do this, you need to have working implementations of all the stages, which means it's not just necessarily working for exactly the auto tests. You need to think about the situations the auto test is trying to tell you about, you know. So the auto tests might just have a random smattering of where the stones are or something like that, but then you might think, okay, that's not just the only place they could be. Maybe I need to think about them in particular patterns and stuff. It's up to you to kind of have a quick look at those things and see if there's examples of things that might break your own code. If you want to go higher than that, if you want to get an HD, and like a lot of people are chasing HDs and stuff, I think like this is something I haven't spoken about that much in the course, is the idea of like what mark you might be aiming for, because aiming for HDs is something that most of the time people can't necessarily do this in every subject that they're doing. There's not usually enough time for a human to get HDs in every subject that they're doing. Usually getting an HD means getting kind of like, if you're a very good student, getting an HD means pushing your average mark a bit higher to get an HD in one subject, which is going to push down your marks in other subjects potentially more. Zach is saying, is there any benefit for getting an HD? I would say the benefit for getting the HD is like you get this little thing on your transcript that makes you like think that you did really well in something. That's it.
You get lots less sleep. That's
yeah. If you want to get less sleep, that's
you can
not
hallucinate a little bit
that's
as you
part
finish
of
the
getting
assignment.
an HD. So yeah, it's just something that I see people chasing them, and I don't necessarily think that's the best thing to do in terms of like learning content in order to get what you wanted to get out of your degree. I mean, for some people, yeah, some people chase them a lot of the time. Other people chase them only in subjects that they really, really care about. You always got to think when you're doing that what was the cost of that? Because for every subject, the amount of work it takes to pass the subject is like, say, X amount of work. So it's like 5 hours a week if you dedicate to the subject. Well, that's not even all the lectures and the tutes. Let's say 10 hours a week dedicated to a subject, you could pass it. If you want to get an HD, it ramps up. It's not just another 10 hours for the other 50 marks in the subject. It's going to end up being more than that, and sometimes at pressure points in the term where you could have been working on other things. Whereas if you push for like a credit, you could do a credit with like 15 hours a week, but then to get a high distinction, you go up to like some stupid amount of work, like 50 hours a week, and it's just not feasible. Right, and so
Also,
that's why it's not for everyone. Yeah.
More generally, the other question is like, what do you want out of this course and what do you want out of uni?
Yeah.
Because if what you want out of this course is to learn absolutely everything about C, then maybe shooting for a 95 or 100 is a reasonable goal. For most people, though, if what you want out of this course is to come away prepared for the future courses and feeling somewhat confident, getting a distinction is more than enough for that. Like, if you've got a credit, you'll be pretty well prepared for 1521, 1531, and 2521. If what you want out of uni is to become, a great software developer, getting a good mark in 1511 is kind of good for that, I guess. But what else is good for that is, doing projects or like joining CSESOC, not to promote CSESOC too much, but all this sort of other stuff. Like, if what you want out of if what you want is to have a good uni experience, it might be that getting an HD in 1511 is not the best way to do that. So again, it sort of comes back to like, what do you actually want? And that's your choice now as a student at university. It's not sort of your choice in high school, but once you get to uni, you can really decide like, what is it that I want to be doing here?
Yeah, I think that's always interesting because coming out of a high school perspective, like you're kind of indoctrinated into get as many marks as you possibly can. Like it's just like get as high a mark as you can, and then you have all these options for uni. But I mean, some people would have known already that like the course that they were going into had a certain cutoff, and they're like, all right, this is how much work I'm gonna do, Whereas at uni, it's like, Now you're getting to what is much closer to a professional situation where it's like there will never be enough time for you to get perfection in the things you're doing. So if there isn't enough time, can you manage your time to get the marks in the things that you want, or learn the things that you want, while you can still survive the life you've chosen for yourself here as a university student and later on as a professional, you know? So I have a lecture on this, which we will go into in week 6, that talks about this kind of thing as well. Yeah. Okay. So that's kind of the marks distribution and the kind of mark, the kind of bits of work that you'll need to do to get whatever different level of marks that you want to get. The other thing I was going to talk about is the free marks. So I don't always want to make everyone start getting tactical about the meta of gaining the maximum marks in the assignment, but I do have these marks here for a reason, and I want people to consider these marks as good marks to get and easy marks to get, and that is these. So the style marks are things that you can do even if you can't solve the problems. You know, so if you think that like the circle explosion stuff for the TNT is like, oh my god, my brain is exploding here, you could still make your code look so good that someone else could work with you on it, and between a group of you, you'd be able to get this code working. If you make your code really, really hard to understand, then it will never reach that point. But if your code's really easy to understand, even if you haven't solved all the problems, you're actually a reasonably valuable programmer. So this is why there's so many marks for style, because when you think about it, 15% of the total marks of the assignment are for style. 15% is the jump between getting a credit and... Yeah, you could get a reasonable credit, so a mark of 70, and if you jump up 15%, you're in a high distinction territory. The marks for style are the difference between a high distinction and a credit. So this is me saying this is important, because this is me knowing that, having worked with lots of people on different projects and things, the one person that you can never work with is the person whose code you can't read. It's like, oh, I can't work with you. Like, it's just, I don't get it. I don't get what's going on, right? So if you can do that, this is where it is. And this is even when you're thinking about it. The less code you've written, the easier it is to make it look good. So you can be like, oh my god, I can't even get stage 1 going, but I'll get 100% for style. You know? So
free... Oh, sorry.
Oh yeah, go for it.
A free tip about this. It is very easy to fix your style if there is one style problem. So if every time you find a style problem, you just fix it, that is so much easier than working on your code for 3 weeks. And then you get to, like, you know, midday on Friday and you're like, all right, time to fix style. You will have about 500 style errors and it will take you a long time. And also, you won't have had the benefit of that good style when you were trying to fix bugs earlier. You will have to deal with the fact that you had bad style. So, like, fix your style as you go. Don't fix it up at the end.
Yeah. That's good. I'm glad you said that, because that's the thing that I said in the code style lecture as well. It's like, no one ever cleans up their room if they have to clean it once a year. But if you clean it once a week, it's actually a minimal amount of work and less work overall. But we never do it. I love how I say that, and I've got like a shelf full of boxes and crap in the background.
I feel
that
really
everyone
called
can
out.
always see in the lecture.
I feel incredibly called out right now.
Sorry?
I feel incredibly called out right now.
Oh, yeah, totally, right? I mean, I always think that, like, it's fine, right? You know, I'm a middling level software engineer. You know, I'm not a great software engineer, but if I'm a good enough teacher, then I can convince other people to be better software engineers than I ever was. And that would be like, you know, that's the goal, right? So, my messy room, don't be like me. Well, although my code is clean, but your code could even be cleaner. Like, you could write your code so well that, you know, you're maintaining it as you go along, and when mistakes come up, you can see really clearly where they are, and so you'll get more performance marks if your style marks are looking like they're 100%.
Also, speaking of people...
Jeffrey Tom's wall only looks clean because he's at UNSW. He's not at home.
That is... Yes, I am not at home at all.
I remember seeing into your house when we've had meetings, and it's reasonably neat. It's definitely neater than mine.
It looks reasonably neat. That's because you can't see the floor.
You aim the camera.
I mean, I can't see the floor either.
Yeah.
But like, yeah. Also, to the people who want to get really good style or really good marks, the best way to get really good marks in future courses is to learn how to have good style now. Because I can't tell you the number of bugs that you will fix or the number of team members who will be happy to have you on their team if you have good style.
Yeah.
It will make the rest of your life easier.
Yeah. It's why we try to hit it so hard so early, these ideas, because we know how valuable they are later on. Okay, so that's everything that we definitely wanted to cover, and we've got 10 minutes left if anyone has any further questions. I think we've been jumping at the questions when people have been asking, so I think we've answered a lot of the questions people had already. But if anyone has any more questions about the assignment, how to approach it, or anything like that, especially if we haven't covered it here, please ask those questions now in chat, and we'll be happy to answer them for the last 10 minutes that we have remaining. If not, we will.
Can I give a little bit of free advice while people are thinking of questions?
Yeah, go for it, because no one's typed anything in.
Two pieces of advice. The first piece of advice is when you are working, like start working on your assignment early. I would recommend by this weekend, have it all set up on your computer, have compiled it and see what it does when it's empty, and maybe try and get even just like scanning in blocks to work. Even if you can't get it to work, just have attempted it. Because that will really give you a sense of like, oh, there's actually stuff here that I need to do. And once you've done that first 5 minutes, it's a lot easier to then spend the next hour or two getting it working. So like set yourself a reminder in your calendar or like an alarm in your calendar, be like, by 5 p.m. on Sunday, I would like to have downloaded and started working on it. That will save your bacon later, because what it means is that when you realize, oh, I actually wish I had some help on this, or I don't understand this thing, you can go to a help session on Monday rather than going to a help session on Friday during week 6 when there are 150 people at the help session. That's the one piece of advice. The second piece of advice is it can often be tempting when you're working on a bug to be like, oh, just one more bug, Mom, then I'll go to bed. And you just keep working on it and keep working on it until it's 3 a.m. So if you're working on something and you're struggling with it, one of the best thing you can do, number one, spend a little bit of time on it, obviously. But number two, take a step back from your computer, go walk around the block, get the blood flowing. Don't just like try and push yourself to fix the problem, because it will take so much longer. Give yourself a few minutes break, come back to it. And one of the luxuries of having 2 weeks to work on this assignment is it's like, if you have a really big problem, take a step away from your code for a day, come back to it tomorrow, you'll see it with fresh eyes. You'll get a better sense of whether the style's any good as well. But apart from that, you can fix the bugs much more easily. So those are my top pieces of advice if people are wondering how to work on the assignment.
All right. Looks like we don't have any final questions, because no one typed anything while you were giving advice then. So we might wrap it up here. So thank you all for coming along. Hopefully this live stream gave people a little bit of idea of the structure of the assignment. We answered a few questions and stuff like that. And if people aren't understanding the assignment, this gives you a boost to get started with it. Jeffrey said that they would come back to Decimal Spiral at some point in the future. That's a good one to rest on, I think.
I have a friend who completed it in their 4th year of university. Yeah. They came back to it. They were like, I want to do it again. I want to see how you do it.
And it still took effort, didn't it? Yeah.
Yep.
Yeah. Because it's like one of those problems where I look at it and go, I don't have, like, nearly everything else in 1511, I just look at it and just go, oh yeah, I've got a solution to that. But Decimal Spiral is like, no, I need to think and I need paper, or else I can't do that. Yeah.
To be clear, that's not to say that it's not possible to solve with what we've taught you. Yep. It's like you know everything you need to solve it. It's just that like it's a problem that you have to think about. Okay. Which is similar to the extension of the assignment as well.
Yeah. All right, let's wrap it up there. Thank you, everyone. For anyone who's here live, see you tomorrow for tomorrow's lecture. All right. Bye.